Hello everybody, welcome back to Arduino for Amateurs. This is episode number 15. It's part 2 on digital sound sensors. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bidhaven Hackerspace. And what I'm talking about today is how we can use a digital sound sensor as a control input in a program, right? So how we can make a circuit behave differently when it receives input from a sound sensor. You probably remember this picture from last week. This is a digital sound sensor. This black circle here, this is a microphone. This blue box with the adjustment screw in it, this adjusts the sensitivity of the microphone. And then these 3 pins are used to integrate it into our circuit. We've got a ground, we've got a power, and then we have an output pin. Now, as I said, this is a digital sound sensor. This is not an analog device, it's a digital device. And as always, what that means is it can produce a 1 or a 0. Either there is sound above the threshold that we've set with the adjustment screw, or there is not. That is it. There's no way of measuring relative volume or relative length of sound. Either it's on or it's off. That's it. So there are analog sound sensors. I have some of those on my desk over here. We'll talk about those in a future video. But for now, we're just looking at a simple digital sound sensor. This is the circuit that we're going to be looking at in this video. Right here, we have our sound sensor, right? And that is powered. We've got this red wire coming off the power rail. We've got the black wire going back to the ground rail. And then we have this orange wire going back here, and that's plugged into pin 4 on our Arduino. Then over here, we have a NeoPixel ring. We've used these in a few videos so far, but these are 16 individually addressable LEDs. Each of these white boxes is an LED and a control chip, and they can all be set individually to different colors, different brightnesses, etc. They're all individual devices that we control programmatically. And those are hooked to power off the power rail here, ground to the ground rail, and then this yellow wire going over here over to pin 7. That is our control wire for the NeoPixel ring. So we're going to write a program that causes a pattern to appear on the NeoPixel ring, and then we'll modify that program in order to control it with the digital sound sensor. So let's get started. Let me go over here. We want this NeoPixel ring chasing lights program that I wrote. So this is a fairly simple program. We've used these NeoPixel rings before, but this is a slightly different technique, so I kind of want to trace through it here. So we start by including our NeoPixel library, defining the pin that our NeoPixel ring is plugged into. It's plugged into pin 7, setting the integer num pixels to 16 because we have 16 LEDs on our ring. These are available in different sizes, as few as, I think, 5 or 6 LEDs, or you can use these same libraries for something like a string of Christmas lights. You can have 50 lights in a sequence. As long as it's still that WS2812 standard, it's still going to be individually addressable. Then we instantiate our Adafruit NeoPixel object. We're calling it pixels. And then we have a few variables here that we're using to keep track of the program flow. We have an array called color list. We'll talk about that more in just a second. We have a long called placeholder. We'll talk about that a little more in a second. And then a couple of integer counters, one called cycle counter up here, one called color counter. Those are both set to 0 to begin with. Now, what is the array for? As you may have noticed, the array is 16 items long. An array, if you haven't run into one of these in programming parlance before, an array is just a list. So in this case, the list has 16 items in it. Being good computer scientists as we are, we start counting at 0. So those list items are referred to as 0 through 15. So if we want to retrieve or write one individual value on the list, we use the name of the list, in this case color list, square bracket, and then the index, the place in the list that we want to modify. So if we want to modify the first value in the list, we refer to that as color list 0. The last item in the list, color list 15, right? And then all the ones in between have their respective values. So you can just think of that like a shopping list or like a sheet of graph paper with a value in each box, whatever helps you to visualize it. But What this color list is just a list of 16 values that are long integers. And then placeholder is another long integer. We'll see what that's for in just a moment. When we go into setup here, we initialize our pixels object, our NeoPixel ring. We set the brightness to 20. We clear out any values that are in there, and then we turn it on. So this is just to get our NeoPixel ring up and running, apply power to it, turn it on, make sure it's ready to go. And then we have 2 for loops here. And this is the first place that we're going to start seeing how we're using this ring a little bit differently in this exercise. Previously, we've set the ring to all one value, or we've used a list to iterate through it and update them individually. But in this case, what we're doing is we are setting the values in that color list array, and then we're going to map those onto the LEDs. So the first thing we do is we use this for loop for int I equals 0, I less than num pixels, I plus plus. So this is going to go 0, 1, 2, 3, 4, etc. up to 15. And we set the color list array value for I, so for 0, for 1, for 2, for 3, all the items in the list, we set it to 0, 0, 0. That is no color. We set it to black. So when this for loop is done running, we have a 16 color list, and all of those colors are 0. All of them are black. Then we run another for loop. We run it also against color list, but this time you'll notice we're doing I equals I plus 4. So that means 0, then 4, then 8, then 12, then, we're over the number. So just those 4, right? And we're setting those to 25500. So those colors in the list will be set to red, right? So if we look at our list and it's 0, 1, 2, 3, 4, 5, it's going to be red, blank, 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 red, blank, 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 red, etc., right? We're storing all of those values in an array, and then when we get to the loop, we'll map those array values onto the actual LEDs. So that's what happens next when we get to this loop step. The first thing in the loop, we have another for loop. The for loop iterates through color list. So I equals 0, I less than num pixels, I plus plus. Should seem familiar. We're counting through all those values. And then for each value of I, we are setting the pixel color for pixels for our NeoPixel ring to the contents of color list I, right? So what we're doing is we're saying, okay, LED 0 set to the value of color list 0. LED 1 set to the value of color list 1. LED 2 set to the value of color list 2, etc. We're updating the values all the way around the ring, and then we run pixels.show. So we say, okay, all those new values are in there. Turn the ring on, show off those values. Then we increment cycle counter. Cycle counter is just a counter that tracks how many times we go through the loop. And then we delay by half a second. So what happens next? Well, if cycle counter is evenly divisible by 5, that is if cycle counter mod 5 equals 0, so every 5th time we go through the loop, then we're going to call this function called next color. We'll see that in just a minute. All right, almost there, honest. I know this is a little more complicated than the programs we've looked at in the past, but it's going to be worth it, I promise. Okay, this next section of code rotates our colored pixels. So remember, we've got 4 colored pixels, 4 red pixels, 4 red LEDs, and what we want to do is rotate those around the ring. So the first thing we do is we set placeholder equal to the value of color list num pixels minus 1, so color list 15. What does that mean? We're taking the value of the last item in that array and we're sticking it in this variable called placeholder. Now, why are we going to do that? Because we want to preserve that value. Okay, we're putting that kind of in a bucket over on its own, and we'll see why in just a moment. Now, we're running another for loop, but in this case, we're doing it in reverse. Rather than going from 0 up to 15, we're going from 15 down to 0. And what happens is we say for int I equals num pixels minus 1, so I equals 15, run the loop as long as I is greater than 0, so run it from 15 down to 0, I minus minus, so decrement with each trip through the loop. Color list I equals color list I minus 1. Okay, so we start at 15. We set 15 to the value of color list 14. We set 14 to the value of color list 13. We set 13 to the value of color list 12, etc. Until we get all the way down to 0 and we exit the loop. And then we set 0 to placeholder. Now remember, placeholder was the value of 15 at the beginning of all this. We've overwritten 15 with the value of 14. That's why we had to pull it out and put it on the side. So we loop through everything, and then we take that value we set to the side and put it back on at the beginning of the list, right? So all we're doing is we're moving each LED value down 1 in the list, right? Or I'm sorry, up 1 in the list. We're moving it up 1 spot in the array. Okay? So that's what's happening here. Now, this next color function, this is probably the dumbest way to do it, but it's also very readable, so I wanted to keep it this way. Basically, we have that other variable, color counter. We only have 3 options for color. We could put those in a separate array if we wanted to, but that would make the code a little harder to read, so I didn't do that. Basically, what we do is we say, okay, if color counter mod 3, if color counter divided by 3 equals 0, if color counter is 0, or if color counter is 3, or if color counter is 6, right, any evenly divisible value, then what we're going to do is we're going to loop through color list, and any pixel that is not 0, we're going to set to green. Okay? So we're going through that list. We're changing all of the values that are not 0 to green, and then we exit. If color counter mod 3 equals 1, we do the same thing, but we change them to blue. And if color counter mod 3 equals 2, we do the same thing, but we change them to red. So what this is going to do is it's going to update the values in that color list array for us. So if there is a color in the box, no matter where in the array it is, doesn't care where the index is, it's just looking to see if there's something in the box, then change it to the new color. If there's not, then don't. And then once that's all done, it updates the color counter. So the next time it goes through this function, it'll do it again. All right? I hope that wasn't too complicated. Again, if you want this code, just stick something in the comments. I'll put it up on GitHub or something. But let me hold up my device here. Okay, it's slipping out of my hand. There we go. Where is my USB cable? I will plug that in. All right. If I hold it up in front of the camera here, you should see I've got 4 rotating red lights, now green lights, now blue lights, right? So again, what's happening is each time through the loop, the values in that color list array are being adjusted. They're being moved 1 later. If the trip through the loop is evenly divisible by 5, it calls that next color function. Otherwise, it just advances them to the next spot and goes back to the top of the loop. So we just get a nice, even, smooth flow, right? 4 lights. If we want more lights, that's easy to do. We can just adjust this initial setup that changes them. So if we want to do every other light instead of every 4th, we just change that from a 4 to a 2. We upload it, and there you go. Now twice as many lights, right? I think that's probably be a little bit harder to see on the camera, but every other light is lit up and then they're rotating the same way. But I'm going to change that back to 4 because I like 4 better. Okay. So that's a cool technique that you can use for any of these programmable light modules, right? Anything that's got lights that you can individually address. You can build an array that contains the desired color or brightness or whatever characteristic of the different lights, and then use a for loop to pump those values in and then refresh. So let's connect this to our digital sound sensor. Okay, let me open up my other program that I've got here. Now, what I've done is let me unplug this so you don't see the light shining on me from below. What I've done is I've combined that digital sound routine from the last video, and I've integrated it into this chasing lights code. So I added the sound pin. I added sound pin 4. All of the rest of this code is the same. I set sound pin to an input. So digital pin 4 is an input pin. Okay. And then going down here, the only difference you'll see is if digital read sound pin equals low, then call next color. So previously it would call next color every 5th time through the loop, right? And we still have the cycle counter, but we're not using it for that anymore. Instead, we're just saying if there's noise, change the color, basically, right? We're making it respond to the environment instead of responding to the value in that counter. So let me plug this back in. All right, I will upload this to send the new stuff into my routine. Oh, my Arduino's falling off the tray here. Okay, and you'll see it's just staying on red right now, right? Because again, I'm not using the counter to change the color. I'm going to use sound. So if I blow on the side of the microphone here, that's a little less disturbing to my family than blowing the whistle here in my office. You'll see it changes the color. So the microphone was activated, the voltage dropped on that output pin, and then it activated that next color function. I can do it again, and I'll change it to blue. Right? So if I want to build circuits and lighting that are responsive to the environment, these digital sound sensors are a good bet. Right? They can be hooked up at a distance using those longer DuPont wires. You could put them around an environment so that the circuit responds to different levels of sound coming from different places. You can do a lot of cool stuff. So that is my lesson on how to use digital sound sensors to affect a light ring. I hope you found it useful, and I'll see you in the next video.